Hello everyone, this is Sudhir working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to demonstrate about the impact of jet-on wings. This is a completely different experiment and which is a starting application of the turbine's part. Okay, so what is the significance of this experiment? So through this experiment, we are going to calculate how much force is being exerted by the jet of water on a typical wave. Okay, means generally in the hydropower plants, we are going to get the electricity with the help of the turbines. So how the turbines work? When the water is going to strike at a with high pressure, then the turbines starts rotating. So when it starts rotating, it creates some mechanical energy, and that mechanical energy, when it is coupled to shafts or generators, it produces electrical energy. But here, the basic component here, what we are going to discuss is that with what force a jet of water can strike a plate. Okay, so that is the starting point of the application of our turbine. And this is going to be work under the principle of momentum equation. This is going to be work under the principle of momentum equation, which can be stated that the force acting on the wave is equal to the product of mass and velocity of the flowing water in the same direction. So that is called as a momentum definition. Now with that momentum definition, we are going to see the working principle of this apparatus. So this is the whole apparatus which is showing for the impact of jet-on waves. Here the waves are of different types. So it may be a flat wave or it may be a curved wave. And inside here you can see a flat wave which is already fixed inside this machine. And here you can see a curved wave. Since the inner surface of the wave is curved, so that's why it got the name as curved wave. Apart from these two, we have like a airfoil shape of the vane also is present. So, and if you're going to take the Pelton wheel turbine, the shape of the vane is a bucket type. And depending upon the type of the instrument, the type of the vane is also going to be present here. Now coming back to the experiment, let us see what are the physical apparatus which we require in order to start the experiment. Basically, we require some source of water, and that water is collected in a collecting tank, or we can call it as a storage tank. And this is obviously at the lower level, and in order to raise its level or to the required elevation, we require a pump, and this is going to work with the help of some external energy, and that is an electrical energy. And through this, the water is going to flow. That is the inlet pipe. We can say it as an inlet pipe. At the inlet pipe, at the end of the inlet pipe, we have a jet. We have a jet here. We have a jet here. So what is the jet? It is which we can call it as the reduced cross-sectional diameter. Okay, so if you're going to take the diameter of the pipe, and when it comes to here, the cross-sectional diameter of the pipe is going to be reduced gradually. Why? Because if the diameter of the pipe has been reduced gradually, and therefore the speed of the particle is going to be decreased, and hence the pressure is going to be increased. So with that principle, the diameter of the jet, the diameter of the pipe has been gradually decreased, and at the top of this jet we have a vane. Of course, this is removable, and whenever it is when the experiment has been completed, then we can remove it and we can replace it with the curved vane. So why we have the different types of the vanes? Because maybe it's due to its working efficiency, then some different types of the vanes are going to be present. Then another important apparatus which we require is that weight. That is at the top of this box, we can see a weight. We can see an weight which is an automatic gauge which we are going to apply on the vane. Okay, the application of this weight box I will be telling you just after a few minutes. Then another important part of the experiment is that collecting tank. Obviously we know that it collects some water that is coming through this nozzle, and it will be collected here, and this is here it is a piezometric scale that is fitted to a collecting tank, and through this piezometric scale the level of the water can be easily identified. Okay, now another important part here is that we have an pressure gauge reading here. Okay, so these are all the apparatus which are essential for carrying out this experiment. Now, in order to carry out this experiment, our main aim of this experiment is to determine the coefficient of impact. Coefficient of impact means here also we are going to calculate the difference in the actual force to the theoretical force. Actual force to the theoretical force. So what is meant by theoretical force? So depending upon the cross section of the wave and based on the momentum application, we are going to calculate how much force it can exert. So in that case, no type of the losses are being considered, and hence it is called as a theoretical force. But if you are going to calculate some actual force, obviously it may involve with some losses, and therefore we are going to have some losses that is called as an actual force. Now the ratio between the actual force to the theoretical force is called as a coefficient of impact. Now our main aim of this experiment is to calculate the coefficient of impact. So here in the case of our theoretical force, depending upon the shape of the wave, the theoretical force formula is going to be varied accordingly. Now as we are going to consider for our demonstration purpose a flat wave and as well as a curved wave. So flat wave, in that the theoretical formula is given by rho a v square. That is rho into a into v square. What is meant by rho? That is mass density of the water in kilogram per meter cube. That is 1000 kilogram per meter cube. A is the cross sectional area of the jet, and v is the velocity of the water that is striking the jet through the nozzle in meters per second. And similarly, for a curved wave, the theoretical formula is going to be Fa theoretical is equal to rho into a into v square into 1 plus cos theta. Since it is having some curved shape inside the surface, so therefore it will be having some deviation angle. So that theta we are going to add it here. Okay, so this is the theoretical formula which we require in order to calculate the theoretical formula for curved wave or maybe for flat wave respectively. Then coming back to the experiment, here when we switch on the water, automatically the water in this collecting in this storage tank will be raised up, and therefore the water is going to be pumped here. So before starting of the pump, if any air is entrapped in this pipe, with the help of the priming action, the air bubbles should be removed from this. So with this is the pipe in which we are going to do the priming. Then when the water flows here, obviously it will be reached here and it will be started striking that plate. So our main aim is to calculate the force, with how much force it is going to be strike that plate. So that we are going to calculate with the help of theoretical formula. Just now we have discussed some of the formulas. Yeah, since it is a flat plate, we are going to use only F is equal to, that is theoretical force is equal to rho a v square. Okay, rho is the mass density of water again, and a is the cross sectional area of the nozzle, and v is the velocity of the water that is flowing through the pipe. And again here we need to calculate F actual. Okay, so how do you calculate that F actual? With the help of this weight, that is we are going to apply some weight. We are going to impose some weight on this rod that is called as a fulcrum rod. Okay, so for what purpose we are going to apply? So basically, if you are going to see the working condition of a turbine, when the water is going to strike, it is going to be rotated with some velocities at higher magnitude. But here what happens? Since it is a stationary one, we are not going to consider to be rotating or to be moving with some velocity. In order to keep it in the stationary position, means even after striking, when for example, if two persons are there, and if a person has been struck by another person, obviously there will be change in the displacement, and hence there will be a movement, there will be a change of movement or change of position of the body. But that is going to be happen in general. But here also, if you are going to take, when this vein is going to strike with a certain force, obviously it should displace from its original position. But that should not happen in our case. Means we are going to calculate the force exerted by the jet of water on a fixed flat vein, on a fixed flat vein, or on a fixed curved vein. So for that purpose, we are going to apply some loads in the opposite direction to the jet of water, in the opposite direction to the jet of water, and hence we can restore its position without moving from original position. So this actual we are going to calculate in terms of kilograms. When it is multiplied with the g, that is acceleration due to gravity, obviously we are going to get it in newtons, and obviously the F theoretical is also we are getting in newtons. So once if you get it in newtons, this actual force and also this theoretical force in newtons, obviously we can take the ratio of those two magnitudes here, that is F actual by F theoretical. We are going to get the coefficient of impact. So here for different types of the pressures, so here you can see that operating valve here. So initially we are going to operate this valve for a certain amount of the pressure. So under that certain amount of the pressure, we are going to calculate. Why? Because here the force is going to be varied according to the pressure, and hence how you know that? Depending upon the weight we are going to apply against to the jet of water. If you are going to apply more load, obviously there is a more force, and if you are going to apply less load, obviously there is a less force. Then how can you know that whether it is more force or less force? By operating this valve, either we can increase the pressure or we can decrease the pressure. So due to that change in the pressure, we are going to calculate for different types of the readings of different pressure gauge readings, and therefore we are going to calculate F theoretical and as well as the F actual. Okay, now in this formula we have a small thing, that is F theoretical is equal to rho into A into V square. What is meant by V? That is the velocity of the liquid particles that is flowing through the pipe. So in order to calculate that velocity of the liquid particles, again we require that collecting tank. Okay, indirectly we are going to apply the continuity equation. We are going to apply the continuity equation. So what is the continuity equation? Q is equal to A into V. Okay, so we require that V value. V is equal to what? Q by A. But what is meant by Q here? That is Q actual. Again, Q actual can be determined by using the formula A into R by T. So what is meant by A? That is area of the collecting tank here. That is the surface area of the collecting tank. And R is the level of water that is required in this piezometric tube. And T is the time taken to fill that R, either for 10 centimeters or 5 centimeters or 3 centimeters, according to the pressure. We are going to calculate with respect to this stopwatch. Using this stopwatch, we are going to calculate the time taken for that R value, and therefore we are going to determine the Q actual. That Q actual in turn is useful for the determination of what the V square by 2g, that is the velocity head. So in that equation, all the parameters are known except the unknown is the F theoretical, and hence if the theoretical formula is known, we can directly calculate the F actual by using this loading device, and therefore we can calculate the ratio of F actual by F theoretical. Now repeat this experiment for maybe 3 or 4 readings, and then take the average of all those readings, and finally we are going to get the coefficient of impact of jet, whether it is a stationary, whether it is a curved vein or a flat vein. But remember that the condition is a stationary one. So with this, we had seen the demonstration of the impact of jet on veins. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.